Okay, this is the end of the year final review, the calculator OK portion. So we'll go through this. I'll demo on the calculator how to do certain things. So hope this helps. It says number 1, use the x-intercept method to find the solution of x cubed minus 10x squared plus 8x plus 64 equals 0. What I'm asking you to do is go over to your calculator and go ahead and put that polynomial into the y equals menu. So we have x to the third minus 10x squared plus 8x plus 64. So you enter that in. Then you go ahead and go to second trace, which is the calculate menu. You should be familiar with this menu. In the calculate menu, you should know how to use all the first 5 here. Value just calculates the value. You put in a certain x value to that function, it will give you the y value output. That's a good way to evaluate a polynomial when you plug in a number. 0 is what we're going to use. That's finding the zeros. So we're going to hit enter. Might want to change the window on this. I'm actually going to go ahead and hit zoom. And let's go back here. Zoom and Z standard is number 6. It'll change the graphing window to a standard graphing window. It goes 10 in each direction from the origin. And it looks like it may have died on me here. Okay, we got it back up and running. We're going to go ahead and find the zeros using the x-intercept method on our calculator. It's going to ask for a left bound, and you can see right here x equals negative 0.15. That's where x is right now. If we go a little bit farther left, as we get closer to x equals negative 2, that cursor should come through here. There it is. So left bound, we want to make sure we're below the x-axis, below this first. You'll see the little hand here, the little arrow. We want to be below this first x-intercept. So that's a good left bound right there. If I go right arrow once, it places my cursor above it. So that's a good right bound. And then guess just needs to be somewhere in between. So my first zero is x equals negative 2. So that's one of the solutions. And then you go through that process to find the other two, which are 4 and 8. So that's the process for finding the solutions to a polynomial equation using the x-intercept method. Problem number 2, you're given a function and asked to find the inverse of it. Process for finding the inverse of this function is to switch x and y and solve for y. So I'm going to switch x and y. Oh, you have to give me a minute here. I've got to now calibrate this thing. So let me calibrate it and I'll come right back. All right, so we'll switch x and y and see if we can solve for y. So the first thing I'm going to do is divide over the 2. So I have 1/2 x equals y minus 4. The opposite of squaring would be to take the square root. So you could have a square root sign over this. So it's divide by 2, take the square root of each side, and then finally add 4 to each side. And so we should add a plus or minus on here from when we took the square root of each side. Final answer is going to be y equals that thing, this thing right here, the plus or minus, just down a little bit. So it'll be, number down, y equals 4 plus or minus square root of 1/2 x equals y. So this is our inverse. Sometimes what we'll use is a little f inverse of x instead of calling it y. That's the symbolism. But the process is to switch x and y and go through the algebra to solve for y, if you're able to. Okay, number 3 says if negative 3, 7 is on the graph of y equals f of x, name a point on f inverse of x. So just think about the process we went through here on number 2. To find an equation or function for the inverse of y equals 2 times x minus 4 squared, we switched x and y and solved for y. Well, if I'm just given one point to find a point on f inverse of x, if this is a point on f of x, we just switch x and y. And there it is. So there's 1 point on the inverse of f of x if negative 3, 7 is a point defined by the function f of x. And number 4, if f of x equals 3x cubed plus 2x minus 1 and g of x equals 2x plus 7, find h of negative 3 when h equals f composed with g. So what this is asking for, if h equals f composed with g, I'm asking for f of g of negative 3. And so we can start by plugging in negative 3 to g. So it looks like this, 2 times negative 3 plus 7. And now I'm asking for f of negative 6 plus 7 is 1. And then f of 1, put that in to the outer function. So that's 3 times 1 cubed plus 2 times 1 minus 1, which gives me 4. All right, going on to the next section of problems here, 5a. To decide if the following are even, and I told you how to decide that, replace x with negative x. And if you end up with the same function, no signs change, then it's even. Or odd, replace x and y with negative x and negative y. So replace both x and y with negative x and negative y and see if you get the same equation. And if that's the case, it's odd. So let's do that quick test here on A and B. So here, I'm going to replace x with negative x. So y equals 3 and negative x to the 4th plus 2 negative x squared minus 7, which of course equals exactly what I started with because of those even powers. So this is therefore even. Okay, and one of the tests for oddness here, we can look at 5b here. You could have switched, I guess, we could have tested this for oddness here on 5a, but as you can see, if I replaced y with negative y, I would have the exact opposite of what I started with. So I'm going to be able to replace x and y. As a matter of fact, that's one way to, another way to test for oddness is just to replace x with negative x and see if you get the exact opposite of what you started with. And so it's another way to do it. Our textbook, I think, talked about testing for oddness by replacing x and y with negative x and negative y and seeing what happens. Now, on 5b, if I were to replace x with negative x, you can see right here, if I replace that with negative x, here, of course, it wouldn't change anything. But if I replace that 3xy term with a negative x, it's going to change the sign on that. So this one I can rule out as being even. Just kind of have to run through the tests. Replace x with negative x, see if you get the same equation. If you do, then it's even. If not, then now let's test for oddness. So here we go. I'm going to test, see if this is odd. So replace y with negative y. Replace x with negative x. Y with negative y. And see if we get the same equation. So see that we do here. These two negatives equal positive. Negative times a negative is a positive. So plus 3xy equals negative x squared plus 5, which is exactly what I started with. So that is odd. All right, number 6. It says if f of x equals 2 minus 4x squared over x minus 1, find f of I, and then rationalize the denominator. So f of I simply means plug in I everywhere you see an x. And then this is the I, the complex I that we were familiar with from Advanced Algebra 2 when we were first introduced to it in the context of solving quadratics. So I squared, remember, is equal to negative 1. So keep that in mind. Gotta remember that. So we have 2 minus 4 times negative 1 over I minus 1, which equals 6 over I minus 1. Rationalizing the denominator. Actually, we're doing complex division is what we're doing. So we're going to multiply by the conjugate here and not have any I in the bottom. So we're going to multiply by I plus 1 over I plus 1, parentheses around it. So we end up with 6I plus 6 over I squared minus 1. And let's move this down a bit. The I squared minus 1 is going to equal, let's go ahead and write the top down, negative 1 minus 1, which is negative 2. So I have 6I plus 6 over negative 2. That can be simplified by dividing negative 2 into each term to negative 3I minus 3. So that's my final answer. That's number 6. All right, number 7. It says list all possible rational zeros of t of x. Now I'm not asking you to find them. I actually put an a sub 1 and a sub 2 in there, but we're just using the theorem, the rational root theorem, to find all possible rational zeros. What we mean by that is, what are all the possibilities for values that if you plug them in for x would make that function t of x equals 0. So they are plus or minus the ratio of the last term over the first term. So it's basically plus or minus all the factors of 16, which are 1, 2, 4, 8, 16, over plus or minus all the factors of 9, which are 1, 3, and 9. So if I list all those out, here's what I've got. We've got plus or minus 1, plus or minus 1/3, plus or minus, let's stop writing the plus or minus. Well, we could just think of 1 plus or minus through the whole thing. Let's just do that. So plus or minus 1/9. Let me just put 1 plus or minus in here, and then I'm going to stop writing plus or minus. It's going to take forever here. So 1/3. So plus or minus 1, 1/3, 1/9. Let's list the rest. 2. So now I've moved on to the 2 over 1. And then the 2 over 3, and then the 2 over 9. So 2 over 3, 2 over 9. And we'll just keep going. Now we move to the 4, so it's plus or minus 4 over 1, 4 over 3, 4 over 9. And then we move to the 8, and it's plus or minus 8, 8 over 3, 8 over 9. So 8, 8 over 3, 8 over 9. And then finally move to the 16, so it's plus or minus 16, 16 over 3, 16 over 9. So just listing all the possible things we have to plug in, and we hope not to have that many combinations. But a lot of ours, plus or minus 1 worked with a lot of the ones we've done, and then we use our synthetic division to divide and bring that down to a cubic, and then go ahead and go through the process again, bring it down to a quadratic, and then we can factor the quadratic or use the quadratic formula on it to find all of our zeros or all of our factors. All right, number 8 says determine if the following are roots of p of x equals x cubed minus 10x squared plus 36x minus 40. Find a real root, then synthetically divide to reduce the polynomial. So what you could do on this is I listed all the different ones I wanted you to check. So 3. Deciding if that's a root is as easy as just plugging in 3 for x and seeing if you get 0. And if you plug in 3, you'll find you do not get 0. So 3 is not a root. Negative 2, same thing. It's not a root because you will not get 0. Now if you plug in 2, you will find that you get 0. And so that should key us in here. I'm going to go ahead and erase what we've got up here from our list of roots. But 2 actually works. It's the first one in that list that works. So if I synthetically divide 2 into the coefficients of this, we've got a 1 as a coefficient of x cubed, negative 10 as the coefficient of x squared, 36 and negative 40. Bring down the 1, negative 8. And so we can see remainder 0. That 2 does divide into there. So 2 is a root. We're left with x squared minus 8x plus 20. Set that equal to 0 and solve. Now, that one, you are not going to be able to find factors that work for that one. So that means we use our quadratic formula. See what happens here. So x equals opposite of b, 8 plus or minus square root of b squared, 64 minus 4 times 1 times c is 20 all over 2 times 1. So x equals 8 plus or minus, let's see, 64 minus 80. So 64 minus 80 is a negative 16. And that negative 16 squared to negative 16 is going to give me 4i over 2. And so I have x equals, divide the 2 into each one, 4 plus or minus 2i. So 4 plus I and 4 minus 2i are the other two roots. So I gave you options there. 4 minus 2i is yes, it's a root. 1 plus 2i is not a root. The other root would have to be 4 minus 2i, and then you have all 3 roots. So here are 2 of them, and the 2 up here was the third root. So those are the 3 values that when you plugged into p of x, 4x will make that equal to 0. Number 9 says, what is the domain of this function g of x? And can you write it in interval notation? So let's kind of pick this apart. We know, pretty common, we know that here on the bottom, x plus 7 cannot equal 0, right? So x cannot equal negative 7. So we know that right off the bat. So that's going to have to be part of our domain expression. Also, we know that right here, x squared minus 36 must be greater than or equal to 0. It's okay if it equals 0, but it must be greater than or equal to 0. So if you think about this, we've got a greater than or equal to an inequality. So we know that the zeros are going to be negative 6 is a 0, and positive 6 is 0. It breaks this number line into 1, 2, 3 regions. And so I'm asking you, where is the quadratic equation x squared minus 36 greater than 0? Or in other words, when is it above the x-axis? So if I were to draw the quadratic through here, I know the zeros would be at negative 6 and 6. And the function x squared minus 36 will be above 0. Let's go ahead and fill in negative 6 and 6 because of this greater than or equal to sign. But it'll be equal to or above above the x-axis, to the left of negative 6 and to the right of 6. So on a number line, I'd basically have, we can see it for the most part. You can almost see it here. I could fill it in here. So above that, to the left of that. Now we've got one other issue though, and that is at x equals negative 7. So right over here, at x equals negative 7, I do have a hole there. So let's go ahead and fill that in. So that's what my number line looks like. So if I were to write this in interval notation, we're going to start over here at negative infinity. We're going to come all the way up to negative 7, have an open parenthesis there, and then union, open parenthesis, negative 7 up to and including 6. So we'll have closed brackets there. And then a union, now we jump over to 6 and go all the way to infinity. So that's what it looks like in interval notation. This is saying in words, the domain goes from negative infinity to negative 7. You got a hole at negative 7, so you got to jump over it. Then you go from negative 7 to 6. That's all filled in. So anything between negative 7 and negative 6 would work in this function. And then from 6 to infinity. All right. Number 10 here. On to number 10. Number 10 says solve for x. So we're going to quickly solve this for x in each of these cases. So this is in the logarithms section. So solving for x, here's what we're going to do to bring that variable power down, where you're going to take the log of each side. And we can take log base 10, or we could take ln. It's your choice. I'm going to take log base 10. So I have log of 3 to the 4x minus 1 equals log of 28. Now by the properties of logarithms, I can rewrite this as 4x minus 1 times log of 3 equals log of 28. Isolate the 4x minus 1, divide over the log of 3, so that's log of 28 divided by log of 3, and then go ahead and add the 1 over and divide by 4. So x equals log 28 divided by log 3 plus 1, and then that whole thing divided by 4. And I can plug that into my calculator. Just got to use careful use of parentheses here, and calculate what x is equal to approximately. X is equal to about 1.0083. We don't want to round to 1, because that would be like saying, okay, if I plug in 1 up here in the original equation, 4x, 4 times 1 is 4, 4 minus 1 is 3, 3 to the third is actually 27, not 28. So even this right here is an approximation. See the squiggly equals, but 1.0083 is fairly close to the value that will make that equation true. All right, B, we have an e in here. So let's go ahead and take divide by 9 first. So e to the 3x equals 24 over 9. To get rid of that e, I'm going to take ln of each side, because ln of e is 1. So take ln of each side on this one. And bring down the 3x. ln of e, like I said, is 1. Final step is divide ln of 24 over 9 by 3, and plug it into your calculator. Get x is about equal to 0.327. All right. C, you got to use the properties of logarithms first to make this into a single logarithm. So this is log base 4 of x times x minus 6 equals 2. Now use the definition. We have a base here of 4, a power of 2, and an answer of x times x minus 6. So it's 4 squared equals x squared minus 6x. I'm going to go ahead and distribute that x in this step. So this is 0 equals x squared minus 6x minus 16. And then I go ahead and factor. Now my factors are x plus 2 times x minus 8. So solutions are x, possible solutions I should say, are x equals negative 2 or x equals 8. One of these is extraneous. If I were to take negative 2 and plug it in up here, I'd be asking for log base 4 of, well, let's see, is that word? Log base 4 of, plug it up here, log base 4 of negative 8 up here, you'd see that, and log base 4 of negative 2, so it does not work. So that's extraneous, take it out, it doesn't work in the original, x equals 8 does. If you plug it in, you'll see that it does, and that's it. So let's go on to the next one here. All right, number 11, we're getting into vectors here. It says convert the vector 6, negative 7 to magnitude direction form. Okay, so 6, negative 7 is down here in the fourth quadrant. So we need to find theta and we need to find r. Okay, so, or the magnitude, we're calling it magnitude in the vector section. It looks like that. So magnitude is equal to the square root of 6 squared plus negative 7 squared. And so that is equal to about 9.22. And theta is equal to inverse tangent of negative 7 over 6, which is about equal to negative 49.4 degrees. And then if we just add 360 to that, we'll call it alpha. Alpha is equal to 360 plus negative 49.4 degrees. That'll give us the positive angle going counterclockwise around, which is 310.6 degrees. And so in magnitude direction form, that's when we have the cosines and sines in it. It's 9.22 cosine of 310.6 degrees in the I direction plus 9.22 sine of 310.6 degrees in the J direction. So there it is. All right, matrices. Find the multiplicative inverse of that matrix. So what we have to do first is find the determinant. The determinant is found by multiplying the main diagonal. So we have 5 times 4 main diagonal here. So 5 times 4 minus negative 3 times negative 8. And so I get 20 minus 24, which is negative 4. Then what we want to do is take 1 over the determinant, 1 over negative 4, and multiply that by the following matrix. We switch the 2 on the main diagonal, 4 and 5, instead of 5 and 4, and we change the signs on the other diagonal, the 3 and 8. And then we go ahead and divide each term by negative 4. So my inverse is negative 1, negative 2, negative 3/4, and negative 5/4. So that is my inverse matrix. So once again, find the determinant, crisscross multiplying there, subtract the two products, divide that determinant into each term after you've swapped the 2 on the main diagonal. We circle them here and change the sign on those 2. All right, 13 says solve the equation. So this one, you could plug it right into your calculator. I guess you could have done the other one too, but good to know how to do that 2 by 2 by hand. We did that when we were in that unit by hand. So number 13, you would enter in a 3 by 3 matrix. It would look like this. Let's do that over here. So we go to, it may vary on calculator versions of how to access the matrix. So I'm going to go edit, 3 by 3 matrix. So here we go. Make sure it's 3 by 3. It'll change the size there. We're going to enter in the coefficients of the left-hand side, which are 1, negative 2, and 4. And the next row is 1, 1, 13, Next row is negative 2, 6, negative 1. So here's my coefficient matrix. I'm going to go ahead and hit matrix again. Oops. Quit out of here. Hit matrix again. Second X inverse. Go over to edit. Enter in my 3 by 1 matrix. That's number 2, matrix B. And my 3 by 1 matrix is the answer matrix. It's 6 and 6 and negative 10. Then I'm going to quit out of there and do some matrix algebra. So hit second X inverse key to book the matrix. I'm going to take matrix A inverse, so you're going to hit the X inverse on that. And then second matrix, second X inverse, number 2. And so it's going to do A inverse B. That's our matrix equation for finding X. And negative 14, negative 6, and 2 are my X, Y, and Z. So there it is. Number 14, I was asking on 14 if you find one positive and one negative angle in radians, which are coterminal. It means have the same ray coming out from the origin as 3 pi over 8. So we're just going to add plus or minus 2 pi to this, basically, and that's the same as having 3 pi over 8 plus or minus. Get a common denominator, 16 pi over 8. So we end up with, if you add it to it, that's 19 pi over 8. Or, if you subtract it, that's negative 13 pi over 8. That's it. All right, number 15. Given cosine of alpha equals negative 2/5 and sine of alpha is less than 0. So that puts us in, let's see here, one of the bottom. Sine of alpha being less than 0 is one of these 2 quadrants here. The fact that cosine is negative puts us in this quadrant here. So if I draw a picture of what alpha looks like, there's my alpha angle. Cosine is adjacent over hypotenuse, so this is 2 and this is 5, so not quite the scale. A little more down than it is up, so maybe triangle a little more like this. Here's alpha here, here's my 2, here's my 5. And we got to find x, that opposite side here probably. So it says find sine and tangent. Okay, so using Pythagorean theorem of x equals square root of 5 squared minus 2 squared, x equals square root of 21. Now I have everything I need to find sine of alpha and tangent of alpha. So remember, sine of alpha is opposite, which was square root of 21 over hypotenuse. And let's think about our sine. We are in the third quadrant, so it's going to be negative square root of 21 over 5. And tangent is opposite over adjacent, so square root of 21 over 2. And because I'm in the third quadrant, negative over a negative is going to give me a positive. All right, number 16. Let's state the amplitude, period, phase shift, and vertical shift of this equation. So one thing we need to do on this first, and that is factor out the 4. Factor out the 4, I'm left with x plus pi over 4 minus 2, and then we can go through amplitude is the absolute value of that, which is 6. Period, let's see, period can be found by taking this guy right here, which is b, and we know that period equals 2 pi over b, and so it's 2 pi over 4 or pi over 2, that's my period. Then we're going to take this guy right here, and the opposite of that sign right there is going to tell me my phase shift, so negative pi over 4, and then my vertical shift is negative 2. So I got it right there. All right. 17a, what is the period and phase shift of y equals, so I got to first factor out a 3 halves, factor out a 3 halves, and then write what is left over. So I have x minus, it's 3 halves times what will give me pi over 4? 3 halves times what will give me pi over 4? So y equals, go ahead and put it 2/3 over here. It's pi over 6. Y equals pi over 6. That's a pi over 6 right there. So I've gone ahead and rewritten that. Now I can answer the question. It says, what is the period and phase shift? The phase shift is pi over 6. Period, you got to take this 3 over 2, solve the same equation I did over here. So 2 pi over 3 over 2 is going to be 2 pi times 2 over 3, which is 4 pi over 3. So period is equal to 4 pi over 3. All right. In part B, it says how many complete cycles does it complete over the interval from 0 to 16 pi? So we're going to take 16 pi and divide it by 4 pi over 3, which is the same as 16 pi times the reciprocal of that, 3 over 4 pi, and 4n, so it looks like 12 cycles. All right, just moving right along here. This is the longest of the 3 reviews I have for you, so hang in there. Number 18, for what values of x in the interval negative pi over 2 to pi over 2 is 4 cosine squared of x equal to 3? All right, so we're going to solve within this region here. All right, so first divide by 4, so cosine squared x equals 3/4. Really important skill to have here as you go into calculus, being able to solve these trigonometric equations. So divide by 4, I'm going to take the square root of each side here, so cosine of x, don't forget it's a plus or minus square root of 3 over 2, and you should recognize that. Root 3 over 2 is some ratio on your unit circle. And then finally, x equals inverse cosine of that plus or minus square root of 3 over 2. So thinking about here on the back up to my picture, we're talking about our cosine is positive root 3 over 2, negative root 3 over 2. So on the interval from negative pi over 2 to pi over 2, cosine is only going to be positive. So we have this ray right here and this ray right here both have arcs, represent arcs whose cosines are positive root 3 over 2. You're not going to worry about the ones over here and over here because I asked you to stay between negative pi over 2 and pi over 2, which keeps us in here. And so x is going to equal plus or minus pi over 6 in radians. All right, number 19, it says solve, and it gives you a polynomial type equation here. So we're going to solve this by factoring like we would a quadratic. So q equals 0, and remember we're on 0 to pi, so we're just going to draw a picture on that here to here. So we have 2 cosine theta and cosine theta. I'm thinking of cosine theta kind of like x's. It's like you have 2x squared plus x minus 1. Pretty easy to factor. We have a negative 1 here and a positive 1. So we set each equal to 0, 2 cosine theta minus 1 equals 0, or cosine theta plus 1 equals 0. So I've got cosine theta equals negative 1, cosine theta equals 1/2. What is the angle theta in radians at which cosine ratio is 1/2? So I'll list that, but we're only listing on 0 to pi. So cosine theta is 1/2. Right here, right up here it would be. It's not as far out, farther up. So that angle would be pi over 3. And then cosine theta equals negative 1. Let's see, it's less than or equal to, so we can include pi. So pi is the other solution. All right, so those are my 2 solutions to that equation. Pay attention to the interval over which we're solving. All right, number 20, it says evaluate tangent. Let's go to the next one here. Evaluate tangent of inverse sine of negative 8 over 17. So just like we do with composition of functions, we're going to work from the inside out. Okay? So first of all, inverse sine of negative 8 over 17. Remember, the range of inverse sine is between here and here. So we're going to fix out all that, and then we see that it's negative, so that puts it down here in the 4th quadrant. So 8 over 17, the picture is going to look like this. We've got 17 is the hypotenuse, the 8 is the opposite, and that's actually a Pythagorean triple if you use, well, If you don't recognize the Pythagorean triple, just use Pythagorean theorem to find that other side of the right triangle, which is 15. So inverse sine of negative 8 over 17. Inverse sine of negative 8 over 17 here. This right here represents an angle. So let's call that angle alpha. So what we're asking for is tangent of alpha, but alpha is a part of this triangle right here that we've drawn with those three lengths. Now we know tangent is defined to be opposite over adjacent, and in this fourth quadrant we also know that tangent has to be negative, so it's negative 8 over 15. So we're just using this right here, this negative 8 over 17, to figure out what quadrant we're in, as well as the missing side length of the right triangle form there, so that then we can use the definition of tangent, opposite over adjacent, to find the ratio of that particular angle to that right triangle. All right, number 21 says find the value of cosine x plus y when x and y are in quadrant 1. Now I'm going to give you this formula. You don't need to memorize it. Formula of cosine x plus y equals cosine x, cosine y, sine is different, minus sine x sine y. And so we'll plug in here. We know sine of x is 24 25ths, sine of y is 3/5. So let's see here. Let's move this over to sine y. So let's go ahead and plug in cosine of x. Now, a little bit of work to do. We realize that we don't know cosine x or cosine y. We do know sine x is 24 over 25. And we do know sine of y is 3/5, but we don't know cosine x, cosine y. So we got to do some drawing here, pictures. So for this one over here, sine x 24 over 25. So that's 24 there. This is 25. Also a Pythagorean triple here. If you don't see it, you can use the Pythagorean theorem, but this down here is 7. So it tells me cosine of x is equal to 7 over 25. So I can fill in cosine of x using my picture. And then over here, this other guy, let's use a different color, draw a picture for sine of y. Sine of y equals 3/5. So might look something like this. There's my right angle, there's y. Opposite is 3, hypotenuse is 5, that means the adjacent is 4. So cosine y equals 4/5. So I can place 4/5 in for cosine. So we got to draw the picture first, fill in the blank for cosine x, cosine y, and then we can find cosine of x plus y. So we got 28 over 125 minus 72 over 125, which equals negative 44 over 125, and so that is cosine of x plus y in this case. All right, 22, it says what is the simplified form of, so here we're going to use another formula. Let's go ahead and write down the formula we're going to use. This is going to be, well, it's the sine of the difference of two angles. Now remember the sine formula keeps the signs. We have sine alpha, and we have a mixture of trig functions in here. So we have cosine of 270 degrees. Keep the sine, and then it's cosine alpha and sine of 270. Now we can go ahead and plug in. We can't do anything with sine of alpha, but cosine of 270, if you think about the picture, we're all the way around to here, that's going to be a 0 minus cosine of alpha. Sine of 270 is going to be -1. The y-coordinate there is -1. This term's gone. Negative and negative is a positive. That simplifies to cosine of alpha. All right, next one, cosine. So now we're using the cosine difference. Oh, cosine of 2 beta. Okay, cosine of 2 beta. Oh, let's see. I got to do b first. Sorry. Going back here to b. Cosine of pi over 6 minus x. So let's go ahead and use our formula. The cosine of the difference. So it's cosine pi over 6, and then cosine of x. Different sign. Sine of pi over 6, sine of x. And cosine of pi over 6 is going to be root 3 over 2 times cosine of x. And then right here, plus sine of pi over 6 is 1/2. And so we have 1/2 of sine of x, and it doesn't simplify any further. You can stop right there. All right, 23. Now we're going to use a double angle formula. Cosine 2 beta. Let's write down the formula first. Cosine 2 beta equals cosine squared beta minus sine squared beta. It kind of looks like the Pythagorean identity, but has a minus sign in there. So we know what sine of beta is. It's negative 5/13, so I can go and plug that in and square it. We don't know cosine squared of beta. Let's go ahead and find it. So if sine of beta is negative 5/13, then all right, so if we draw our picture here, let's go draw our picture. We'll go ahead and figure out what cosine beta is. So it says, and beta terminates in quadrant 4, so we're in quadrant 4. And sine is negative 5/13, so let's draw it over here. So here's beta, opposite is 5, this is 13, so this is going to be 12. So that means cosine of beta is equal to 12/13 adjacent over hypotenuse. So we can put 12/13 in here, square it, and go ahead and simplify that. So it's 144 over 169 minus 25 over 169, which is 119 over 169. All right. 24 on the last page here. So 24a says solve the following triangles with the given information. So solving a triangle means find all the angles and all the sides. Let's go ahead and draw a quick picture here. We've got A, B, let's put 10 in between there. C here, we'll put, well, not going to be scale, but C is 10, okay. And A is 8. Oh, well, we're not going to worry about scale here. And B is 5. And so we got to go ahead and find an angle here. So we can pick an angle. I'm going to go ahead and choose A to find. And I'm going to use the law of cosines to find that. So law of cosine says if I want to find angle A, I need to make sure that this guy is opposite side of the equation. So it's 8 squared equals 5 squared plus 10 squared minus 2 times 5 times 10 cosine of A. And I got to solve, so just move everything over. So you're going to end up going 8 squared minus 5 squared minus 10 squared and dividing by negative 2 times 5 times 10, and that equals cosine of A. So you got to put this correctly into your calculator, carefully using parentheses around these guys. And you should get a value that's between negative 1 and 1, otherwise it'll give you an error message. Remember, cosine is between negative 1 and 1. Take inverse cosine of that decimal you get between negative 1 and 1. You should get A is about 52.4 degrees. So this guy here is 52.4 degrees. We've got to find one other angle, and then we can use 180 minus the sum of those two to get the third angle. So to find the other angle, maybe set up law of sine. So sine of 52.4 over 8 equals sine of B. 5, cross multiply, and cross multiply and solve, you get B equals 29.7 degrees. Leaving, if you do 180 minus the sum of those two, 97.9 degrees for the third angle C. Alright, so that's part A. Let's go on to part B. We've got another picture here. Let's go ahead and draw this one out. See what we got. Here's draw my generic triangle. Here's A, B, C. We're going to think about scale. We've got 20 degrees here. Maybe 120. It works out okay. 129 there. 31 here. So given that we've been given two of the angles, we can find that third angle B by just saying, okay, we got to add up to 180. Side B is 210. So I'm going to use law of sines here. Sine of 20 over 210, and then your choice, you get sine of 129 over A, cross multiply and solve, you get A is about equal to 477.2. And then run it through another, you can't use Pythagorean theorem, this is not a right triangle, but another comparison here of sine 20 over 210 equals sine of 31 over C, cross multiply, take inverse sine, could see is about equal to 316, 2. So that is solving for that triangle. All right, do a little bit of polar here, and then we're going to wrap it up. It says convert 4, -4 to polar coordinates. So 4, -4, I like to draw a picture here. 4 out, 4 down, so right down here. That angle, 4 over -4 down, is a 45-degree angle. Right, we're the same out as we are down, so you can figure out the angle pretty easily. Go around to here if you want a positive angle there. We're going to say that's theta equals 7 pi over 4. And then r is equal to the square root of 4 squared plus -4 squared. 16 plus 16 is 32. Square root of 32, think of it as 16 times 2. Square root of 16 is 4 root 2. So polar form is 4 root 2, comma, theta, 7 pi over 4. So polar form is just r, comma, theta form. All right, now this one is in polar form, and we're going to convert it to rectangular. So let's draw a picture. 3 out, pi over 3 up, so somewhere here. 3 out there, this angle is pi over 3. Conversion is just to take, calculate 3 cosine pi over 3, comma 3 sine pi over 3, and those will give me the xy rectangular coordinates. Cosine of pi over 3 is 1/2. Sine of pi over 3 is root 3 over 2. So I've got 3/2, comma 3 root 3 over 2. Those are my rectangular coordinates. All right, 27. It says draw the polar graph of r equals 4 sine 2 theta. So this is a sine graph. We're going to figure out where it starts by setting 2 theta equal to pi over 2. So theta equals pi over 4, so we start at pi over 4. And we know that it's 4 sine 2 theta, so we start 1, 2, 3, 4 out here. Well, that's where the tip of that first flower petal will be. Now, let's go ahead and draw that. The other thing we know is that there are going to be, since this is an even number in front of theta, there are going to be 2 times 2 or 4 petals, and the petals are going to be evenly spaced. So if we start at pi over 4, every pi over 4 units, we have another petal. There's got to be 4 of them. So that's it. So yeah, every 90 degrees, we're going to end up with another petal there. All right, 28. What is the focus and directrix of the parabola x equals 1 over 12 y squared? Okay, so remember, it's x equals 1 over 4p y squared. This is a sideways opening parabola. It goes through the origin. Let's go ahead and find p. So I take 1 over 4p. That's got to equal 1 over 12. 4p equals 12. P equals 3. So that tells me 1, 2, 3. 1, 2, 3 from there. So I've got a focus at 3, 0, and then I've got 1, 2, 3 to the left. The directrix of x equals -3, and that's it. Okay, that concludes the pre-calculus final review calculator. Okay, so